All right, let's do section 5.1 and answer some of the questions that were left on that. First of all, I'm going to start with number 8. And number 8 is asking you, oh, this is 5.2, gotta find it here. It's right there. Here it is. 8 gives us true or false. The domain of a composite function is the same as g of x. F composite g of x, does it have the same domain as g of x? Yes, except if generally yes. But if you put something into G, it has to be able to go into G, so that's why it's generally yes, but what you get out of G has to be able to go into F. And so as long as domain elements for G allow you to put it into G, and they result in range elements that can be put into the domain of F, can be put into F, then that's true. So it sort of is yes, except that it has to be able, the range elements that come out of G have to be able to go into F. And so that would be the restriction on that. So not quite yes, but kind of yes. You do have to be able to put them into G, but they have to be able to go on through F, and so therefore sometimes it's not yes. It's some of them, sometimes you have to restrict even what you go put into G. That's the answer to 8. 10. 10 had a table, and I'll write that table out real quickly here because people were having trouble with these table things. And I did these a while back, and so I didn't repeat them when we got to these. So it said if x is minus 3, minus 2, minus 1, 0, 1, 2, 3. And for those values, we know what f of x is going to be. 11, 9, 7, 5, 3, 1, minus 1. And g of x is negative 8, negative 3, 0, 1, 0, negative 3, negative 8. So there's f and g. Now, it said find f composite g of 1. And so to do that, you put 1 into G. So 1 into G gives you 0. So this becomes f of 0, which becomes, and if you put 0 into f, you get 5. Okay? Number B says find f of g of 2. F composite g of 2. So we've got to put 2 into G. 2 into G is negative 3. So we'll have f of negative 3. So that's, we got negative 3 out of this. Now we've got to put negative 3 into f. And negative 3 into f is 11. C. We're supposed to find g of f of 2. So we just reversed them. So now we got to put 2 into f first, and we get something. 2 into f is 1. So now we're supposed to take that answer and put it into G. So we're going to put 1 into G, and we get 0. And then D. We're supposed to find g of f of 3. So 3 is supposed to go into f. 3 into f is -1. And now we're supposed to put that f of 3 answer, the y value and x is 3, on f into g. And g of -1 is 0. Excuse me. Now we'll do E. E says find g of g composite g of 1. So we put 1 into g. 1 into g gives us 0. So then we're supposed to find, and then take that 0 and put it into g. So we put 0 into g, we get back to 1. And f of 3. So we got to put 3 into f, take that result out. 3 into f is -1, and put that into f, the second f here. And so -1 into f is 7. And that's number 10. That's how you're supposed to work that one out. Next one was 12. And then I'm not surprised that these are even, because people just kind of wrote answers down and were in the book. But 12, and this has a graph. Do I want to copy the graph? I don't think I want to copy the graph. Maybe I can put the book over here and kind of help you see what I'm doing. So there's the graph, and I'm supposed to do on 12a g of f of 1. So I'm supposed to put 1 into f and then that answer into g. So f is this V-shaped line. If I put 1 into f, I get -1. So that becomes -1. F of 1 is -1, and I got to put that into g. And g is this curvy line, and when I put -1 into g, I get 3. So that's the answer to 12a. Now let's do 12b. 12b says g of f of 5. So g composite f of 5. I got to put 5 into f, get that result, and put it into g. 5 into f gives me 1 right there. So I got to find g of 1. 1 into g gives me 4. And now I'm going to do C, which says find f of g of 0. F of g of 0. So I got to put 0 into g and see where we end up. 0 into g is 5. And now I got to find f of 5. And 5 in f is 1. And finally D, which says find f of g of 2. F of g of 2. F composite g of 2. So I got to put 2 into g. 2 into g gives me 2. 2 goes in, comes out as a 2. So then I get f of 2. Because I got to put it into g and then take that and put it into f. And 2 into f is -2. Okay. That was number 12. And then 20. 20 says Where's that here? For 20, the directions are to find f of g of 4, then find g of f of 2, f of 1, and g of 0. And what do we know? Oh, they're going to change f and g on us. So number 20, f of x is the absolute value, absolute value of x minus 2. And g of x is 3 over x squared plus 2. So here it says put 4 into g. So I'm going to get 3 over 4 squared, 16, 17, 18. 3/18. So this will change to f of 3/18, which is going to be 3/18 minus 2. 2 is 18. 18/18 twice, 36/18. So I got to take 3/18 minus 36/18, which is minus 33/18, and the absolute value of that is 33/18. Now it says put 2 into f. 2 minus 2 is 0. Absolute value of 0 is 0, so I got to find g of 0, which is 3 over 2. I put 0 in for the x squared. Now f of 1. So I got to put 1 into f. So 1 minus 2 is negative 1, so I have the absolute value of negative 1, which is 1. So I got f of 1 is 1, and then I got to put that into f. So f of 1, which we just kind of did, is 1 minus 2, which is minus 1. So minus 1 in absolute value is 1. So this comes out to equal 1. Now it says put 0 into g, take that answer and put it into g. So if I put 0 into g, I get 3 over 3, 0 squared plus 2 is 2. I get 1.5. And now I got to put that into the other g. So I get 3 over 3/2 squared plus 2. So 3/2 squared is 9/4 plus 2. 9/4 is 2 1/4, so we got 4 1/4. 3 over 4 1/4. And I could leave it like that, but let's see, that's 16, 17 quarters. So I got 3 divided by 17 fourths, and I can multiply by 4 17ths and 4 17ths, and I end up with 3 times 4 is 12 over 1 times 17 is 17, and these cancel to be 1, and so 12/17 is my answer for the last part of 20. And now let's see, 39. One more problem, 39 in this section. 39 says show that f of g of x and g of f of x equals x, where f is 2x and g f of x and g of x is 1/2 x. So basically show that these are inverses of each other. So f of g of x means I put x into g. X into g is 1/2 x. It says what it says it is. So I got to put into f 1/2 x, which means I'm replacing the x in here with 1/2 x, and I get 2 times 1/2 x, which is 1x, or which is just x. So it is an inverse because that went nicely. Oh, and I put the x into g and then into f, and it says do it again for g of f of x. So f of x is 2x, so I'm going to put 2x into g, and that would be 1/2 times 2x, which is x. So pretty much verified that one's the inverse of the other. And that's 5.1.